Number 6, a ruby laser. Again, you do not have to know what that is. One of the goals of this worksheet is to differentiate between what you know and what you don't know, because you might not understand the entire picture, but you know something. So a ruby laser produces red light. Again, doesn't matter. That has a wavelength, okay, now we're getting into stuff we can use, of 500 nanometers. Calculate its energy in joules. So now we're back to the situation where we have to do 2 steps because we have to use both equations, right? So we can only use this equation because the question is given us nanometers. But we need to use this equation because the question is asking us to calculate joules, energy, right, in joules. So we have to end up using this. The only way that we can connect these equations is the value for nu, frequency. So I'll solve this equation for frequency. Again, algebraically rearrange this equation so that it shows frequency is equal to the speed of light over wavelength. Now I have the speed of light. I have the wavelength in meters, and that might seem very, very convoluted, but remember that nano is 10 to the negative 9. So it's very easy for me to turn this nanometers into meters. I take this exact same number that the question has given me and slap a times 10 to the 9th meters on the back of it, and I'm done. I can take that value now and plug it in for wavelength. Now that both values have meters, they can cancel. The meters will cancel, leaving only per second, which is the unit for frequency. Some calculator work will tell me that the frequency is 6.00 times 10 to the 14th per seconds. That's not my final answer, however. It's just the frequency that I plug into this equation to solve for energy. So I'll do that down here. Energy is equal to h nu. This is the value for Planck's constant for h. It's printed on the front top piece of this paper. And then here's the frequency that you just calculated right on top. Some simple calculator work will tell you that this joule has an energy, this photon has an energy of 3.98 times 10 to the 19th joules.